So in this chapter, I want to talk to you guys about virtualization briefly. The concept discussed in this chapter uh, don't really come into picture unless you're doing some really advanced level stuff. The networking, however, the chapters after this are very important and you do need to understand them very well. Anyways, coming back to this is something you are used to seeing at your house or like a computer anywhere. It has one CPU, one network card, some RAM, and this is where computing started even for the bigger organizations. But as the time passed, the machines could be built bigger with multiple CPUs, multiple network cards, more memory, and it just kept going up from there. Now, even though we managed to squeeze in four CPUs and so much memory and four network cards into this physical machine, there's only so far you can go. And people needed more compute capacity. So what they did was they started racking machines like this, one on top of other, into data centers. And it looked like this, which is, I worked with this stuff for about 10 years, not even 10, like 10, 15 years. And if you could look at the top, those small square boxes are individual machines of the size that I'm discussing on the left, the figure on the left. And the screen that you're seeing, that's something we would have to use to physically connect to individual machines to do any management tasks. Still not too bad and doable, but then you go to the back of this machine, and this is what it used to look like sometimes. And we had to figure out connectivity between these machines. And well, you can guess, like, it was a nightmare. So now what we do is we just give managing this whole thing to Amazon, and that's basically cloud computing. So a little more on the evolution of how virtualization works. So this is our big machine right now, or let's say 10 years ago where we started. And on top of that big machine, there is a single OS sitting, and in this OS, different processes will be running. The problem with this situation was if one process goes crazy, it can bring down the whole machine. So it's just one process and taking over the entire physical hardware. So we needed a way to separate these. And so logically, the first thing that we tried was physical partitioning. So in the physical partitioning, the physical machine on top. So inside of one physical machine, we created three smaller physical machines, and they are basically completely separate. Now, this solved one problem, but this is not very efficiently manageable. Like basically the bottom machine has more capacity compared to the top two machines. Now, let's say the bottom machine needs to serve two applications with lower capacity. So that had to be split physically again. Or let's say the top machine needs more capacity. So you have to remove the physical partition. Not very efficient. So a bunch of things happen in the middle, but right now where we are is this. So we still have that big machine, but now and a single operating systems on top of it, which is called a hypervisor. And now this hypervisor creates logical machines. Like it allocates logical resources, these CPUs, this memory, these network cards, they have a logical bonding with each VM, and that communication is handled by the hypervisor. And in the cloud, we basically deal with these VMs. But this is what goes on in the back. Um, Now, the another very important thing which I kind of kept for the end is the hard drives. Now, once again, you can have hard drives inside the machine and you can have hard drives outside the machine. And this kind of becomes important dealing with data centers or, but well, virtual machine data centers, I'm kind of mixing things in my head, but like let's just focus on the cloud computing. And in cloud machines, even though we are not necessarily not, we don't have to think about how the machines are laid out. You have to, at a logical level, know where your disks are. If they're inside the physical machine, they are going to respond a lot faster to anything you are executing on that machine. While if they are on a NAS device, which is basically a network attached storage, it's going to be a little slower. But the benefit of the NAS device, it can be in petabyte and exabyte size. But the internal disks with this physical machine, they can be only so big. So takeaway, we only deal with virtual machines, and the disks, internal disks are faster, the external disks are not. So now let's look at a virtual machine by itself. So this is what you would work with in the cloud. So when somebody asks you, hey, give me an EC2 machine, this is what you're going to look at. You don't know where the actual CPUs are, you don't know where the actual card is, you don't know anything. Like basically the physical locations are not known, but the logical specification is something you are responsible for, like how many network cards this machine will have, how many CPUs it will have, how many disks which are internal is that machine is going to have, and how many are external. So this you need to know, and the consideration here are some loads will require really fast disks. They will use the internal disks, while some loads will require really big disks. They would make use of external disks. Uh, the machines that use shared CPUs, there are two considerations. One is basically, would other machines affect my performance? It won't because of the virtualization. The second consideration is how software require you to use a specific number of CPUs to use a specific number of licenses. And in that case, you have to know where is your machine sitting on a shared hardware or if it is not sitting on a shared hardware. Oh, and that's all I really wanted to cover in this chapter. But this is what you will be creating when you create an EC2 instance. Once you go on the screen to create the EC2 instance, this will make a lot more sense. And that's all I want to cover in the chapter. Thanks.